If you want to write these down as notes, you can. It's really entirely up to you. You guys, the smartboard working out there for you? Okay, thank you. Okay, so I'm just going to give you my version of vector subtraction. It's about a 10-minute little spiel. Okay, so vector subtraction, it's page 105 in the textbook if you're following along with that lousy textbook. Nate, you really got to start learning how to figure out when you need to write notes. Because the professor in a classroom with 200 people is not going to yell out and say, hey, Nate, this is important, write this down. Oh, okay. So, we know that resultant, if we talk about planes in the wind, okay, so we know that the resultant is equal to the plane speed plus the wind speed. So, for example, this one right here, I've got the plane going straight north, and the wind is blowing it east, which results in the plane going at some angle like that. And that's grade 11 physics, or at least it is here. Well, that's what he's going to do, right? It depends on where he wants to go. I mean, if he wants to go here, then that's where he should be steering, right? It's kind of like when your truck needs realignment, and you got to kind of, right, do that little, right? Or the wind's blowing, right? You got to, right? Resultant is plane plus wind. Resultant is plane plus wind. And I tell my grade 11s that the plus sign indicates that you arrange the vectors in a tip to tail fashion. Remember, you guys remember that? Tip to tail, right? So there's the tip of the first one, and there's the tail of the next one. And there's always some kid that says, but Mr. Bennett, these aren't tip to tail here. Are they supposed to be? No. Okay. It's the ones that you are adding are tip to tail. The ones that you're adding are tip to tail. Okay, so we rearrange this, r equals p plus w, we rearrange to solve for either plane or wind speed. So if you're solving for the plane vector, right, you take the w to the other side, it becomes negative, right? This w goes over here, and you get plane is equal to r minus w. Or if you're solving for wind, right, then you take the plane over, and it becomes negative, and you got the wind is r minus p. Okay, so in other words, these are vector subtraction questions. Now, I like to show, give me 30 seconds, Mustafa. I like to show it as plane is equal to resultant plus minus wind. And that's what we do in grade 11. We do that flip thing, remember, from grade 11? You guys might not remember that. Or here it would be wind is equal to resultant plus minus plane. Okay, if you want to think about adding the opposite, we can do it that way. Mustafa, question. Okay. Yeah. Yeah. So what does minus wind mean? It just means in the opposite direction. That's kind of how we dealt with it in grade 11. At least kids that took it from me did. Okay. So this will mean vector subtraction when trying to find, if the question asks for the wind speed or the plane speed or the boat or the current or not the resultant, then quite likely it's going to be vector subtraction. Now, you guys have been taught vector components. Vector subtraction with components is insanely easy, isn't it? Because all it means is instead of adding the components, you just subtract. So it's like a different button on your calculator. That's literally it, right? It's really just the setup that is the hard part, or recognizing that it's vector subtraction. Now, quite often on a worksheet, it'll say vector addition and vector subtraction, so it's pretty easy to figure it out, right? But there are instances, maybe on a test or on a review kind of thing, where you might not see that. Okay. So to subtract vectors by components, like I just said, simply subtract rather than add components. Like, what could be easier than that? Right? Just subtract them. So if you got a situation like this, where you got vector c is equal to a minus b, and there's those vectors, how do we subtract them? Well, we're going to do the components, right? Now, if I said, let's try this, could many of you get a good start on this? Or should I do it, Josh? I should just do it? You guys want me just to do it out there? Yeah? Yeah? Okay. Yeah, okay. I kind of get that impression. Okay. So, let's find, I'm going to stand over here. The components of vector A. So A is east, 26 south. I've been going through this in my grade 11s. There's still some people that have trouble with east and west. I don't know why. North and south, people got no problem with. East and west, write it on your hand. I don't know. East, west, right? So east 26 south is going to be east. And actually, when you do it by components, it's really simple. Go east and then go south, right? Go east and then go south. And the angle is going to be 26, right? Does it have to be to scale, Sam? No, it's just a sketch, right? Draw it big enough that it good works for you. So east 26 south. Yes. In the way of what? This. Yeah, I think you're right, Mitch. I already knew it though, but east 26 south. I'll let you guys fill in the blanks. 12 long, good, right? This length is 12, right? So now we're going to label those sides. I'm going to label this is vector A, so I'm going to label it AX and AY. Is that what Mr. Smigalski used for notation? Right? X and Y. So you have to find those components, right? Okay, so let's write AX is equal to, now A is adjacent to the angle, so it's going to be the cosine. If you want to go back and say cosine equals adjacent over hypotenuse, be my guest. I'm not going to do that. AX is the adjacent one, so it's cosine. So it's going to be 12 cos 26, right? And did I bring, no, what the heck did I do with that calculator? Sam, you be my official calculator. I got my phone here, but 10.78, let's say 10.8. Now, I'm assuming Mr. Smigalski taught you about positives and negatives, right? AX is to the right, so it's going to be positive, right? Now, I like to actually, I didn't do a very good job here. I like to, so if I got room? Oh. I like to do like, put my A's and then my Y's in another column. That's where I like setting it up. Well, I just like having my X's and my Y's in a column. That's the way I like doing it. So I'm going to have to scrunch here. I forgot I was going to do that. So this is going to be 12 sine 26. If one is the cos, does the other one have to be the sine? Yep. What is it? 5.3. Okay. Now it's down, so it's going to be negative, right? Please be very careful with those. Okay? It's important to see into that room, Nate. Here's a better question. Why do you have to ask about it at this point in time? I stopped talking so people could have a chance to write it down and think about things, not so that we could fill in the spaces with meaningless chatter. We're not on the radio here. Dead air is okay. You could be a seat filler like on the Oscars, Nate. Okay, so now I got to do B, right? So B is 8 at east, 14 north. East, 14 north. Just draw those again, right? East, 14 north. East and north. Easy. Cole, what you doing there? Right? Seriously? Okay. East 14 north. And this is the vector is 8 long, right? And we're going to label them with a BX and a BY. And then we're going to solve for them. I like to put my x's above each other, so bx is equal to, now the x this time is again adjacent, so it's going to be 8 cosine 14. Someone help me out. 7.8? Positive or negative? To the right is positive. Are you coming for me to mark something? You got your sheet with you? We got to log in. Yeah, well, it's whatever you. I don't know. Oh my God. Okay, bring me your sheet and I'll mark it on screen. What's up, Bill? Super absorbent paper, right? No, I know it's like coated in like Teflon or something rather. It doesn't absorb water at all. All right. Okay, so we got 7.8. It's positive because it's to the right. The other one's going to be, why did I pick up blue? So this is going to be by 8 sine 14. How much, Nate? 10.9? 1.9, and it's up, so also positive, right? 1.9. Okay. Got a writing tool? Why you needed a backup quarterback? That's good. That's funny. Okay. Next step now, Nate, is to actually do what? Subtract them. And all you do is you just literally, if you want to put a negative sign in there, subtract. Right? So it's going to be 10.8 minus 7.8. Oh, isn't that convenient? I can do that in my head. It's 3.0. And here I've got minus 5.3, and I'm subtracting 1.9. I want to... We'll get to that. I want to see this step, because that tells me you get that it's subtraction. Yeah, what's for what it is, sure. Yeah, yeah. At least I want to see that you subtraction. Fair enough. Okay, someone help me out here. That's going to be 7.3, minus 7.2, right? Okay. So those are this is really our resultant x, and this is our resultant y, right? And then what's the next step, Cole? Yep. Take those components and rebuild it into Pythagoras, right? Positive 3, so to the right. And negative 7.2, so that's going to be down, right? Like, this is sweet. Where's the difference between adding and subtracting? One step, this one right here, where you do the actual subtraction, in here, green, right? That's the only place. Maybe it's just because you're hearing it for the second time. Yeah. Nate's chirping you. I know that's not a surprise, but... Oh, he's rolling the sleeves up. Yeah. It's like I'm pitching the ninth inning here, right? I come in, I throw a couple of fastballs, and I get all the glory. It's exactly, right? Yeah. All right. So now, Nate, what's up? What do I do? What's that? I'm going to go r squared is equal to 3.0 squared plus minus 7.2 squared. I'm going to figure that out. Yeah, hold on. Let's. Yeah. We'll get there. Sam, you doing this for me? Yeah. Okay. Yeah. How much? 16? Oh, then take the square root for me. 7.8. Oh, come on. That's like little boy and girl stuff. Come on. You don't need that. And then the last step, as Nate aptly pointed out, we have to do the inverse tan. Right? That's your favorite step. Not the two-step? Yeah, I've seen that. Absolutely. Makes my knees hurt. Just watching it. I bet it does. Good question. Does it have to be negative? No. We're really just finding out a geometric figure at this point here, right? The negative is just there so that we know that it goes down, and we know that it's going to be south, but if you put the negative in there, it's going to mess things up, right? So treat the negative as a direction. Yeah. Negatives are kind of, yeah, you got to. Good question. What's the answer here? Okay, so we'll say 67. And what are my measurements here? Or what are my directions? It's so easy with components because it's east, right? It's just east. 67 down is south. Like don't you wish I had shown you components in grade 11? Most kids say that. And I say, well, too bad.
So what's the...
That's the answer. 7.8, whatever it is.
7.8, then we do east 67.
Yeah. Yeah, 7.8 whatever's at east 67 south, yes. Okay? How's that sound out there in Grandview and Winnipegosis? Look at they're dancing with excitement. Cold in that room. I've been out there. It's cold. You need a hat. No. Not compared to that. Well, the day I was there was minus 40 outside, so. Okay. Oh! I got it all set up on the next screen here. Jeez, Bennett. Oh, my God. Yeah, I just fooled myself, though. Okay. So, I'm going to give you guys some questions to try. I've sent them out. You guys should have them out there, I hope. There's 2 sheets. There's one that just says subtract the following vectors. Very basic. I've got answers on the bottom and solutions on the back. And I've also got some vector questions. This problem one's here. It's got a QR code on the back. I don't know if I have the solutions, but if you scan it, you'll get to the solutions. Okay? So there you go. I don't know. Did I give you 3? Yeah, I want that one, yeah. They are?
What are the formulas?
I'll come back in a minute. Let me just turn the recording off here. Okay, so first job today is if you haven't completed the vector hand-in that many of you did yesterday, please do that. That's job 1. Job 2, if you're still working on Fred and Barney questions, I need that from a couple people. Do the subtract the following vectors. There's 3 questions there, answers on the back. I guess I'm going to have to do a subtraction hand-in one as well that doesn't have an answer, so I'll have to create one. And then there's a whole whack of problems here. The first problems are obviously addition. The second set of problems are obviously subtraction. So try some of those. We might need to do a little more day of this kind of stuff, but we're aiming for a test Tuesday. Got to get her done. We're overdue here.